Okay. All right, so let's begin our class. So this is the second week of UMTYMP prep. I hope you guys did well the first week, but if not, we're here to learn as always. So let's get started. So today's agenda, we're going to review last week's homework. Then we're going to go into the lecture with the new topics. And the topics we're going to cover are just going to be the rest of the pre-algebra handout that we did last time. So if you still have that pre-algebra handout, we'll be going over the second half of that now. Then we're going to do another mock test. This mock test will be 50 questions this time, 30 minutes. So it's basically a real one, but we gave you 5 more extra minutes because we want to slowly work our way towards the actual real test. But it's still 50 questions and it's harder than last week's practice test. And then we're going to review the test and answer any questions that you have. And we will review some of the topics from last week, like logarithms, which I know some of you guys um, wanted to do a review on, so we were going to do that. All right, so, and if you missed last week's class, that's okay. It was recorded. You can watch it on YouTube. I believe the link was sent out in the email. So yeah. All right. So what topics are we going to cover today? Well, we're going to cover factors, factorials, counting, divisibility, factoring numbers, and we're going to finish up the pre-algebra handout. So maybe you guys have learned this already or not, but factorials, factoring, all of this cool stuff. It's a very basic introduction to number theory, which is a cool subject, but we're going to be learning these amazing and cool things. So it's all about numbers. Okay, so one thing I do want to say again is if you haven't joined the Google Classroom yet, please do so. Eric can put the link in the chat, but here's the code. You can just go to classroom.google.com and enter in the code. But you need to join this Google Classroom if you want to participate in this class because that's where everything is. That's where all the handouts and tests are going to be. So make sure you join this. Okay, yeah, the link is in the chat now, so go ahead and click that. And here are some reminders for homework. So I don't think everyone did the homework, which is a little unfortunate, but that's okay. It is optional. Well, it's optional if you don't want a good grade because it's worth 20% of your grade. But we would highly recommend doing it because if you want to get into the entrance exam, you're going to have to spend a lot of time preparing for it. And homework is a great way to practice for it. There's umpteen cell questions on there and conceptual problems. So I would really recommend doing the homework. It's just as important as doing mock tests. Okay. And again, all the homework is found on Google Classroom, and I can show you guys how to get there. So if we're in the Google Classroom here, we can just go to the Classroom tab and it's called Week 1 Homework. And yeah, you can just view it. So I'm going to go and review the homework now. So let me go ahead and pull it up. All right. Okay, I might not be able to pull it up right next to the whiteboard. So make sure you guys have this pulled up on your own screen if that's possible. So let me just reshare my screen. All right. So the first question is a review question and asks for what PEMDAS is. And we know that here, wait, I might be able to edit here. All right. So can you guys see what I'm writing on the screen?
Yeah.
All right, that's great. So PEMDAS is parentheses. Yeah, I can actually use text here. So we know it's parentheses, then exponents, then multiplication. Oopsies. All right, division, addition, and subtraction. So, right, this is just the very first thing we learned last week is which ones go in which order according to PEMDAS, and here is the order. All right. So now for question two, we want to evaluate this thing. So basically, we just have to use PEMDAS. So what I'm going to do first is evaluate the things in the parentheses first. So I see that we have something in parentheses right here. Let me change the color to blue, darker blue. All right. So I need to evaluate 3 squared plus 1. And to do that, I would evaluate the 3 squared first because it's exponent. So that's 9. So I have 9 plus 1, and that's just going to be 10. All right. So now we have 10 as the first parentheses. And then I'm going to evaluate the second parentheses now. So 1 plus 4 over 2 squared. Well, we have addition, division, and exponentiation, but exponentiation comes first. So I'm going to do that first. 2 squared is 4, and then 4 divided by 4 is 1. So 1 plus 1 is 2. And then I see I have a 1 over 2 here by itself in the parentheses. And we have 2 divided by 1 over 2, basically, and that's 4. And then finally, we have 10 times 2 and then plus 4, which is 24. So 24 is the answer here. Okay, so now let's write the 4 exponent rules. Let me see if I can't control my thing anymore. How do I stop annotating? All right, like that. Let me zoom in. Oh, okay. Clear my drawings. All right. So the 4 exponent rules are the very first one we already know is a to the n times a to the m equals a to the n plus m. And the second one is a to the n to the m equals a to the nm, right? Here's the multiplication one. Here's the adding one up there. And then another one is a to, or 1 over a to the n equals a to the negative n. This is definition. And then what was the other one? M times square root of a to the, or the mth root of a to the n is a to the n over m. And I believe that's all of them. There's also a to the 0 equals 1. I don't think I missed any. I think this is it. Oh, there's also ab to the n equals a to the nb to the n, the distributive rule for exponents. Okay, that should be all of them. And then for logarithms, we have log. Well, this is more than 4 rules, but I think this one and this one are like not really rules, or just kind of special cases. So, all right. So now moving on to logarithms, we have log. Well, let's write the definition first, right? So log base a of x equals b means that a to the x equals b. So that's the definition of the logarithm. And then I'm going to scroll down here. I can't really. All right. Okay. But here's the definition. Now, the first rule is if we have log base c of ab, we can split that into log base c of a plus log base c of b. And similarly, if we do log base c of a over b, we can break that into log base c of a minus log base c of b. And then the other one is log base c of a to the n equals n log base c a. So I believe these are the rules. Well, log base anything of 1 is 0, but so these are the rules. And again, the logarithm ones are really hard. If you are really having a really tough time with them and it's just really difficult, it might not be worth knowing them because they're probably not going to come up on the test. It's very unlikely that they'll come up on the test. So I would prioritize learning the exponent rules because the exponent rules will come up on the test for sure. And the exponent ones are a lot easier to learn. So if you're not really understanding logarithms, that's fine. You don't have to worry about it. I would really focus on the exponent ones first. All right, first and foremost, have the exponent ones down guaranteed. Okay. Now let's move on to question 5. So what is the sum of all the integers from 4 to 56? So last class I gave you the formula where 1 plus 2 plus something all the way to n equals n times n plus 1 over 2. Now, at first glance, it might seem like we should use this, right? Because this is a cool trick and we have an infinite adding, or not infinite, but we have a lot of things added together. So you might say, oh, I want to use this nice little rule. But what's the problem with using this rule on this question? Any insights in the chat? Why is this not the right solution yet?
What is the formula again?
So the formula is 1 plus 2 plus 3 plus 4 all the way to n is n times n plus 1 all over 2.
N times
N
N
plus 1
plus
all over
1.
2. Yeah, right here.
Okay, thank you.
Yeah. So I'm seeing a lot of great um I'm seeing a lot of great insights in the chat right now, and that's because we're not starting at 1, right? That's the
What
hint.
would N be?
So n is the last number or the amount of numbers. So remember that this formula only works if we start at 1. And if we want the sum of all the integers from 4 to 6, we're not starting at 1, we're starting at 4, right? But here's the trick. We can still use this formula. It's just that we have to subtract the numbers from 1 to 4, right? Because if we use this formula, we accidentally added like these 4 numbers, right? Can you guys see that? If we use this formula, which is all the numbers from 1 to n, we accidentally add these, right? So how do we fix that? Well, we would just subtract the ones that we accidentally added, and we actually want to include 4. So yeah, we would subtract these 3 numbers. So we would subtract 1, subtract 2, and subtract 3. So now let's go ahead and solve it. So I'm going to first find the sum of all the numbers from 1 to 56. And using the formula, I know n is 56, right? So we'll do 56 times 57 over 2. And then subtract 1 minus 2 minus 3. So we're going to subtract 6. And when I do that, I get 28 times 57 minus 6. And this is kind of hard to evaluate. So I'm just going to use a calculator. But remember, on the real test, you can't use a calculator. But since we want to get this quickly done, we got 1590. So let's go back here. We got 1590. And then we subtract 6 and we get 1584. That is our answer. All right. So does anyone have any questions on this question? Because this one is pretty difficult.
Um, so in N times N plus 1, is N plus 1 in parentheses?
Yes, it is.
Okay, so I do N plus 1. In this case, the N would be 56, right?
Yep. Yep.
So
Yep.
so basically the equation is 56 times parentheses 56 plus 1, and that's over 2. What does over 2 mean?
Like divide by 2.
Okay, okay,
Yeah.
thank you.
Yeah. All right. Okay. I hope you all get this now. Not really seeing any questions in the chat. So yeah, okay. So basically the strategy is we want to be able to apply our formula, but we do have to realize that we have a little bit of extra stuff, so we just subtract it off at the end. So that's the little trick there. Okay, so for number 6, what is the sum of all the even integers from 1 to 100? So this one is a little bit harder than the previous one, and that's because the previous formula is for all the integers, right? 1, 2, 3, 4, 5, 6, 7, blah, 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 all the way to 100. But we don't want the odd ones. We only want the even ones. So what's will be our strategy to solve this now? We don't want to manually add everything, right? That would be too tedious. So one thing I'm going to do first is I'm going to write out the sum, and I'll skip a few and we'll go all the way to 100. Oh, I wrote all the numbers. That's not good. Okay. 2 plus 4 plus 6 plus all the way to 96 plus 98 plus 100. Okay. So this is what we want to solve. And let me give you guys the first step. So here's the first trick. I'm going to take this number, right? The first two and the last number, and I'm going to add them together. We get 102, right? Now what happens if I add the second number and the second to last number? What do I get? Any insights? Yeah, we get 102 again. Okay, what about the third number and the third to last number? What do I get? I get 102 again. Wow. Do we notice a pattern here? So it seems like if I take the first one and the last one and then I keep going in from both sides, right? Like bam, 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 bam. I always get 102. I'm always going to be adding 102. So now our question becomes, how many times do we have to do this? So how many times do we have to do this? Any insights in the chat? How many times do we have to add by 102? This part is the hard part of the problem. All right. So I'm seeing a lot of 25s in the chat. So let's see if that's right. So how would I solve how many times do I have to add this? What's the approach? Well, I know that let me make this proposition. Let's ignore the right half. Okay? What happens if we just ignore the right half? Well, we can do that, right? Because even if we have a left half number, we'll just have the correct right half number, right? It'll always be there. So now I basically just need to find how many numbers are between 2 and the midway point. And what is the midway point? Any insights? Well, let's try to figure it out. So let's I'm not gonna write it all out, but let's say we just start at like what's something close to the midway point, maybe like 48. So 48, then we're gonna add 50, We're going to add 52 and something, 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 right? It's either 48, 50, or 52. And it's probably not 48. So it's either 50 or 52. And I'm going to say that the midpoint is right here. It's in between these two numbers because these two numbers added together is 102. So we can go from 2 to 50, and that's the left side, all the even numbers from 2 to 50. And how do we find all the even numbers from 2 to 50? Well, this is a lot easier to count, but you could also use a counting strategy, which is you take the last number minus the first number, and you divide it by 2 because we want the even numbers, and then we add 1. And this is 25. There's 25 numbers between 25 even numbers between 2 and 50. Okay. And now we can go to our final step. We did all of this work, right? All of this work, but we need to be careful not to lose track of what our original goal was, and that is to find the sum. And the sum will be 102 times 25, right? Because we figured out we're multiplying 102 25 times. That becomes some number. This multiplication, I guess I can go ahead and do it. But we get the general idea, right? We would get 750. All right. So that one is a very tricky one. I'm you don't have to be too worried, or I'm not surprised if this stumped you because it's a hard question. It utilizes a lot of ideas and you have to really think outside the box on this one. But now that you've seen the solution, I hope that you learned at least one trick that maybe you can apply to the question on the mock test. Because there are going to be some questions like this, maybe not as hard, but definitely using one of these, at least one of these concepts, either realizing that everything is can sum to one number, or counting the amount of numbers between two numbers, or maybe even just multiplication. But I hope you at least learned one thing from this challenging problem. Okay. Oh, it is 250. Did I mess up the multiplication? I might have messed up the multiple. Yeah, I definitely messed up the multiplication here. Okay. That is really, really silly of me. Okay. For the sake of time, let's just put this in a calculator. Good catch, by the way. It is 2550. Okay, I can't believe I messed up the multiplication. That's very silly of me. 2550. Okay. All right, you don't want to be like me messing up multiplication. Okay. But the answer is 2550, not 750. Sorry about that. Great catch in the chat, though. Okay. Now let's move on to the final problem, the challenge problem. There's going to be the UMTYMP style ones after this, but let's review this now. So the challenge problem is this mess. And basically what it wants us to do is use the exponent rules to simplify it. And we're given that AB equals 2. So what can we do with that? Well, I'm not sure yet. So let's just simplify this first and see what happens. Okay. So
Excuse
I'm going to
me?
have to, yep.
When it means AB equals 2, does it like mean like A times B equals 2?
Yeah, it means A times B equals 2.
Okay.
Yep. If you see two variables right next to each other, that means they're multiplied. Okay. So now let's go ahead and simplify this expression. So according to PEMDAS, I'm going to do the thing in the parentheses first, which is a to the 7 over a to the 4th. So what is a to the 7 over a to the 4th? That is a to the 3rd, right? We're using that rule above. So it will become a to the 3rd cubed over b squared times b to the 11. And then what's next? Now I have to do the exponents next, right? PE. E is next. So I'm going to have to do a to the third cubed. And what does that end up being? That becomes a to the ninth, right? We're using that rule up there. I can't really scroll back up, but if you have the exponent notes written down, that's one of the rules, right? And now this becomes my expression. And now it already looks a lot simpler. So let's continue going. So now what's the next step? Well, I don't like how this b to the 11 is kind of hanging on the side, right? So I'm just going to move it onto the numerator, right? So there we go. Not really changing anything. It's just a little change of the notation. Still multiplied though. And now what do I see? I have b to the 11th divided by b squared. I can apply the exponent rule again. And that's going to end up being a to the ninth times b to the ninth. And now that looks really similar to AB, right? I have A and B right next to each other. But now I'm going to do one more rule where I'm going to take out the 9, like kind of factor it out. It's not really factoring, but I'm going to take out the 9 and boom, now we have AB to the ninth power. So this expression is AB all to the ninth power. And we know that AB is 2. So this just becomes 2 to the ninth, and that's 512. So there is our answer. Okay. So now I'm going to go over some of the umpteenth style questions. And oopsies, what happened? Okay, let's go back here. Let's go over the very first one now. So the umpteenth style questions are A, B, C, D, right? We know what those all mean. So question one, we see a lot of square roots. If we remember from last week, Kevin taught us a lot of amazing things about square roots. And immediately on the right-hand side, I see something that I can simplify. How can I do that? Well, this will equal 3 times the square root of 8. And then I'll move the 3 in, which will become the square root of 3 squared times 8, which will be the square root of 9 times 8, which is the square root of 72. So I see that these two are the same. So the first one is C. Now, on the second one, I see that x is positive. So the very first thing I want to do is factor it out. So I'm going to factor this, and we're going to get 2x plus 7. And then on the right-hand side, we're going to get 3x plus 7. And it looks like the right-hand side is bigger. You might want to put D, but it's not D. Even though there's a variable, it's not D because x is positive, right? X is positive. So 3x plus 7 will always be bigger than 2x plus 7, right? They both have plus 7, so if I want to compare them, 2x plus 7 versus 3x plus 7, I can chop off the plus 7, right? Because both sides have that. And now I'm just comparing 2x and 3x. And since x is positive, 3x is always bigger than 2x. So this is B. If x is 1, then the left-hand side is 2 and the right-hand side is 3. So it'd still be B. All right. Now for number 3. Um, I see that I can use exponent rules on the left on quantity A. So that ends up becoming 9x squared y cubed. And boom, it's equal. All right, so now I'm going to hand it off to Kevin to continue the rest of this lecture.
Okay. Give me a second to pull up the homework from last week. I was expecting to start my hand out. Please chill. Okay. So I think Aaron finished on question 2, right? So we're going to start with 3. So for this, it's pretty much just remembering the exponent rules from last week. And the first thing we should keep in mind is that exponents are distributive over multiplication. So so for this, like, okay, as an example, we know that AB to the power of C equals A to the C times B to the C. So in this case, we have that 3xy squared equals 3 squared times x squared times y squared equals 9x squared y squared. And then 9x squared y squared is always the same thing as 9x squared y squared. So the answer to this one is C, despite the variables. So if you picked D just because of the variables, make sure to remember that that's not always the correct answer. Okay, question 4. So, oh, this one's kind of funny. So for question 4, this one uses some of the square root properties from before. But you can't just say like, okay, we know that 123 is greater than 121. So square root of 123 is greater than square root of 121, which is equal to 11. And we also know that square root of 5 is less than 3, and square root of 80 is less than 9. So square root of 5 plus square root of 80 is less than 12. But this doesn't get us anywhere. Like, just knowing that the left side is greater than 11 and the right side is less than 12, you can't make anything of that for sure yet. So we've got to try a different approach. So what we're going to do here is notice that the square root of 80 is actually the square root of 16 times 5. And if you remember what we can do here, we can kind of pull that square out to make it a square root. And the square root of 16 is, oh wait, that's a terrible way to explain. And we know that multiplication, that square roots are distributive across multiplication. So we have 16 times root 5, which is 4 root 5. And then adding root 5 to this, we get 5 root 5. So this is also square root of 25 times square root of 5, which is square root of 125. And since 125 is greater than 123, square root of 125 is greater than square root of 123. So the answer here is B. The square root of 5 plus square root of 80 is greater than the square root of 123. Next question. Log base 3 of 80 and log base 2 of 20. So, uh, of course, we probably don't know the values of these actual numbers, and we don't get a calculator on the UMTYMP exam. So how would we do this? So one thing we should keep in mind is bounding, right? Like finding out whether something is smaller than another thing that we know about or bigger than another thing that we know about. So if we test, or we don't have to know this off the top of our heads, but after some messing around, we might figure out that 3 to the 4th is equal to 81. So log base 3 of 81 is equal to 4. So from this, we know log base 3 of 80 is less than 4. On the other hand, we know that 2 to the 4th power equals 16. So log base 2 of 16 equals 4, and log base 2 of 20 is greater than 4. So since the value of the right side is greater than 4 and the value of the left side is less than 4, we know that the answer here has to be B. Cool. Okay. Question 6 is a pretty standard PEMDAS question. So we'll start with evaluating the left side, which is 12 plus 3 divided by 3 minus 2. So when we look over this, the first thing that we have to do is there are no parentheses, there are no exponents, so we start with multiplication and division. And the only instance of that is going to be this 3 divided by 3, which reduces to a 1. And so we have 12 plus 1 minus 2, and then we have addition and subtraction from left to right next, which gives us 11. And 11 is greater than 3, so the answer here is A. Oh yeah, for the last ones, I guess I should leave the answers up. Okay. 7, I guess there is a trick to this, but you won't learn that until algebra. But you shouldn't really need to use the trick. Uh, if you think these are big numbers and the computation is too complicated, notice that you can split 1001 into 1000 plus 1. And so 999 times 1001 equals 999,000 plus 999 equals 999,999. On the other hand, 1000 squared is 1000000, which is actually one larger than 999,999. So the answer here is B. For those of you saying A, just make sure you watch out for the number of digits. The right side has 7 digits and the left side has 6. So B is, yeah, so the B is bigger. So for question 8, the percent increase from 10 to 14 centimeters and the percent increase from 54 to 58 centimeters. If you guys remember how to do percent increase, essentially what it is um final minus initial. I don't know if you guys know what those words mean actually. One second. End minus start over start. And then if you want it as a percentage, you would multiply it by 100 and add a percent sign at the end. So for the first one, we have 14 minus 10 over 10, which is 4/10. And this is a 40% increase. And then for the second one, we have 58 minus 54 over 54, which is 4 over 54. And we might not know what this percentage is off the top of our heads, but what we do notice is that 4 over 54 is smaller than 4 over 10 because they have the same numerator and 4 over 54 has a larger denominator. So the percent increase of the first one is greater. And the answer is A. Sorry about that. So next for question 9, we have this precondition of X is, sorry, yeah, I had to talk to my dad for a second. For question 9, we have this precondition X is greater than 1, and then we have to compare negative X and negative X squared. So we should note that if X is greater than 1, X squared is greater than X. This is just like how it works. Uh, just because like if you have a number greater than 1, then multiplying it by itself increases its value. But note, however, since there's a negative sign, x squared, negative x squared is more negative than negative x. And so we actually have negative x squared is less than negative x. So the, so the answer here is A. I see one comment about negative times negative equals positive, but remember that PEMDAS says we do exponentiation before uh, multiplication. So instead of it being negative x squared, it's actually negative x squared. If when written like this. If there's parentheses, it's a different story. Lastly, for question 10. So we have to do the fourth root of 0.0001 and the square root of 0.01. This is a pretty hard question, especially without a calculator. But we would first, to make things easier, we want to rewrite this as a fraction. So 0.0001 equals 1 over 10 to the fourth, or 1 over 10,000. Sorry, I got it ahead of myself, which is 1 over 10 to the fourth power. So, so 1 over 10 to the fourth power, the fourth root is just 1 over 10. On the other hand, 0.01 equals 1 over 100, which is 1 over 10 squared. So the square root of 1 over 10 squared equals 1 over 10. And so the two are equal, and the answer is C. Okay, that's all the homework questions. If you guys want to take a picture of the answers for that, if you want to go back and review later, go ahead. Otherwise, all the explanations will be on the recording of the lecture that will be posted later. Cool. So next, I'm going to switch to the handout for today. This is going to be the same handout as the last week's class, but I know we didn't completely get through that, so I'm going to continue on the later half of the handout. So I'm pretty sure we finished sum of many numbers last week. Is that correct? Can you guys confirm in chat? We should be starting factorization now, right?
Yeah, that's right.
Cool. Okay, so we're going to start on factorization. And the first thing to note here is the definition of a prime number. So some of you might know this already, but a prime number is a number such that its only factors are 1 and itself. So for example, 2 is a prime number because the only things you can divide it by are 2 and 1. Same with 3 and 5. If anybody knows any other prime numbers, you can put those in the chat right now. Just seeing. Oh yeah, yeah. You guys can send chat messages to the directors or the teachers of this class. I see 7. That's a good one. That is actually the next one. 11, 13. Yeah. Okay. So a lot of good answers in chat here. And so one important thing is if every number that's not prime is composite, which means and all composite numbers can be written as a product of prime numbers, except one. One is in a special category. One doesn't fall into either. But composite numbers always have more than two factors, and they can always be expressed as they can always be factored into a product of prime numbers. So that process is going to be called prime factorization. You guys can stop sending in prime numbers. That's good. So essentially for any composite number or any prime number, I guess it's kind of pointless for prime numbers. You can break it down into a product of a bunch of primes. And again, that's called prime factorization. So the example here is 24. So what we start with is noticing that 24, well, the first thing that you guys probably see is that it's divisible by 2. So we divide it by 2 and we get 2 and 12, right? This is still 24. And now 2 is prime, so we focus on the 12. And we notice it's still divisible by 2. So we take out another 2 and a 6.
Can I ask a question?
Yeah, what's up?
So you put 24 over 2. That's division, right?
That is division, yes.
So
Means division.
how would I read a fraction?
What do you mean, how would you read a
Like
fraction?
um You
Oh,
have 24 over 2, and that
yes.
looks like a fraction. So how do I know if it's a fraction or not?
Division and fractions are the same thing. A fraction is just a way to write a number as a division problem. Like 1/3
Oh.
is 1 divided by 3. They're the same thing. Yeah,
Oh,
great question.
okay.
Great
Thank
question,
you.
though. That does clear that up. But yeah, and then finally 6 we can split into 2 and 3, and we finally notice, oh, 2 and 3 are both primes, so we're done. And we have 2 times 2 times 2 times 3, but notice that this is just 2 cubed times 3, and this is the prime factorization of 24. So just as a quick exercise, does anybody want to give me the prime factorization of 30? Just send it in chat to any one of us, and we'll let you know if this is correct. Fucking handwriting.
Is this PDF itself like a thing that can teach us?
I think we'll make it accessible to you guys through the Google Classroom sometime in the near future.
Okay, okay, thank you.
Yeah. Okay. A lot of good answers in chat here. The correct answer is 2 times 3 times 5. So to walk you guys through the process, again, 30 is even, and since it's not 2, that means we can divide it by 2 to yield 2 and something else. So we have 2 and 15. 15, we noticed, is also not a prime number. It can be divided into 3 and 5. So now we have 2, 3, and 5. So 30 is 2 times 3 times 5. It I got a bunch of answers like 5 times 2 times 3, 3 times 5 times 2. You can technically write it in any order. It shouldn't be a problem. It's just like conventional, like it's normal in the math community to write from smallest to largest. But either way is correct. If you have questions, probably direct them to either Eric or Aditya because it's kind of hard for me to respond to things in the chat and teach at the same time. So for divisibility rules, okay, divisibility rules, right? I mentioned above that you can immediately see that 24 and 30 are divisible by 2. And this is probably the simplest divisibility rule. Most of you guys probably know this. But if the last digit is even, then the whole number is even and it's divisible by 2. So that is the 2 divisibility rule. Divisibility by 1 is kind of pointless because you don't need to know. Okay, every number is divisible by 1 is wrong. But divisibility rules focus on for integers specifically. You wouldn't use the term divisible with any other type of number. So divisibility by 1, all integers are divisible by 1. All even numbers are divisible by 2. And the way to tell whether a number is even is if the last digit is even. 3 is a little bit more special. If you add up the digits and the sum is a multiple of 3, then the number is divisible by 3. You can do this repeatedly, right? Like if you had 1, 2, 3, 4, 5, 6, 7, 8, 9, and you wanted to know if it was divisible by 3, you could add up all of these digits and you'd get 45. And if you're still not sure whether this is divisible by 3, you can just do it again. And at this point, you should know that 9 is divisible by 3. And so that way you know that this whole number is actually a multiple of 3. But yeah, you can use the 3 divisibility rule as many times as you want on a number, and it'll still work. So for 4, it's a lot like the 2 divisibility rule, except it uses the last 2 digits. So for a number like 173056 or something, you're like, is this divisible by 4? I can't tell. But luckily, you don't have to look at this nasty part of the number. You can just focus on 56. And then as long as you know that like 56 is 4 times 14, then you know that the entire number is a multiple of 4. 5 is probably the one that you guys know the second best after 2. If a number ends in a 5 or a 0, then it's a multiple of 5. So that would be like 3, 7, 4, 0, 5. You see the 5 here, you know it's a multiple of 5. You see like 6, 6, 4, 1, 2, 0. You see the 0, you know it's a multiple of 5. Those are pretty straightforward. And then 6, uh, uh, if a number is both divisible by 2 and divisible by 3, it's also divisible by 6. So just the combination of those two divisibility rules would be 6. This works for any two numbers, by the way. Like if it's asking about a multiple of, oh wait, there's 10 later. But if it's wondering about say 12, right? You can just combine the 3 and the 4 divisibility rules and you'll get the 12. So for 7, yeah, 7 is a little complicated. 7 is more complicated than the others. But basically what you do is you take the last digit, like let's take the number 112 for now. Yeah, this one's like really obsolete. This one doesn't come up often. But let's take the 2. Guys, try not to annotate on the screen. But if we would take the 2 and we wouldn't double it, so we get 4, and we subtract it from the first few digits. And from here we would have 7. And we know that 7 is a multiple of 7, so this works. If it's a bigger number, like say, what's a good example? Like 2198. Then we would take this 8, double it, 16, subtract here, 203. We still don't know if this is a multiple of 7. So we take this 3, double it, 6, subtract 6, and we get 14. And we're like, oh, that's a multiple of 7. So we know that the original number is also a multiple of 7. Okay. Uh, Next, for the 8 divisibility rule, you might be starting to see a pattern here with like 2, 4, 8, 16 at any power of 2. This pattern actually does hold. But for 8, as long as the last 3 digits are divisible by 8, it'll work. This one's a little bit tougher because you might not know which 3-digit numbers are divisible by 8, but it does make things a lot simpler. So like 8, let's say 87064. You would look at the last 3 digits and you'd be like, oh, I know 64 is divisible by 8. Oops. I know 64 is divisible by 8. So I know that this whole number is also a multiple of 8. Uh, Akil, wait, ask Eric the question, but I'm not sure I understand what you're trying to ask. So please elaborate on that to him. Or ask Eric or Aditya. Okay, for the 9 divisibility rule, it's a lot like the 3 divisibility rule. As long as the digits sum up to a multiple of 9, then the number is a multiple of 9. So for example, 111111111. You might see this and be really disoriented, but if you just count the ones, you'll notice that there's 9 of them. And 9 is a multiple of 9, so this is also a multiple of 9. Cool. Okay. And then 10 is very simple. 10 is just, if it ends in a 0, it's a multiple of 10. This is also a combination of the 2 divisibility rule and the 5 divisibility rule. So there is that perk. So as long as it ends in a 0, like blah, blah, blah. As long as it ends in a 0, it's a multiple of 10. Okay. And then 11 is a little bit annoying to do. Let me think of another. Okay, yeah. So 11, for example, so 11 is kind of special. Let's use the number 14641 as an example, right? So what you do is you take the sum of alternating digits, right? So here we have 1 plus 6 plus 1, and then the other alternating sum, so 4 plus 4. And you take the difference, right? So this is 8, subtract, it gets 0. If the difference is a multiple of 11, then the whole number is a multiple of 11. So 0 is technically a multiple of 11. It's 0 times 11, which means that we know that this number is a multiple of 11. That one's a little bit confusing. You might want to look a little more into that later. Okay, so now divisibility rules, you can use these to figure out what something's divisible by, and then you can divide it to help find your prime factorization. So now using a prime factorization, we can figure out how many factors a number has. So what you do is, let's say you have a prime factorization and it's 2 cubed times 3 to the 5th power times 5 squared, right? And it's asking you, how many factors does this have? Well, that might look like a very intimidating task. You might try multiplying things together, but then you might think like, I don't know what 48600 I don't know how many factors that has. Well, there's a really simple way to do this using the prime factorization. So what you do is you take each power and you add 1 to it. So 3 plus
Evan,
1.
I just
Yes?
had a request for you to scroll up a little bit. I think they
Oh,
did
yeah.
something.
Let me get that out of the way.
Okay, you can let me Shreyans, you can let me know when you're done.
All right, take a picture of the divisibility rules if you want. They're really handy.
Okay, he's done.
Okay, great. Uh, just kind of annoying to navigate. Okay, so oh dear, everything disappeared. Okay, I'll just clear it for now. And we'll write that back in. So, right, okay. 2 cubed times 3 to the 5th times 5 squared. So we do this 3 plus 1, 5 plus 1, 2 plus 1, and we multiply them all together. So this would be 4 times 6 times 3, which is just 72. So you know that this number has 72 factors. So I guess there's an example shown here with the number of factors of 180, but the answer is already on that, I guess. You can look over that, and then once you're done, try finding the number of factors of 84. So see if you can do that. I'll give you guys, say, a minute to do this. This one might take a bit.
Can I ask a question?
Yeah, go ahead.
Could you repeat the 6 and 7 divisibility rules?
Oh, right. So you guys can keep working on 84. For 6, it's just it just needs to satisfy both the 2 divisibility rule and the 3 divisibility rule. So like if it needs to end in an even number and the sum of the digits need to be divisible by 3. Because like if something is divisible by both 2 and 3, it's got to be divisible by 6 as well. Uh, oh, wait, guys. Finding the prime factorization of 84 is an important step, but it should not be your final answer. Your final answer should be the amount of factors of 84. But yeah, anyways. And then for 7, again, it's pretty complicated, but let's say it's 91. You take this You take the units digit, you multiply it by 2, and you subtract it from the rest of the number. So like for 91, you take the 1, you multiply by 2, you get 2, you subtract that 2 from 9, and you get 7. And since 7 is a multiple of 7, so is 91. So here, so yeah, but that one's pretty complicated. You shouldn't really need that.
Okay, thank you.
Yeah. Okay, I have one correct answer, but I figured this one's pretty hard. So again, the method we have to find out the number of factors is using the prime factorization. So the first step we should do is to find the prime factorization. So first we see that the number is even, so it's divisible by 2, and we divide it by 2. So we have 2 times 42. And then we look at 42 now because 2 is already prime. And we notice that it's still even. So we get to 2 and 21. 21 is not even, so we're done with the 2's finally. But we should know that this is 3 times 7. Or if we don't, we can try the 3 divisibility rule. We do 2 plus 1 equals 3, and we know that 21 has to be a multiple of 3. So we divide it by 3 and we get 3 and 7. And both of these numbers are prime. So we have 2 times 2 times 3 times 7, which is just 2 squared times 3 times 7. And so we do our trick from before. We do 2 plus 1, 3 plus, or oh my God, 1 plus 1 and 1 plus 1. And we get 3, 2, and 2. We multiply them together and we get 12. So the correct answer for this one would be 12. There are 12 factors of 84. So now we should be getting to the final topic of the day, and that is factorials. So the idea of a factorial is basically you just multiply all of the numbers, you multiply a number with multiply an integer with all of the integers below it. So for example, like the 5 factorial is given here. 5 factorial equals 5 times 4 times 3 times 2 times 1. It's like 20 times 3 times 2 times 1. 60 times 2 times 1 is 120. So 5 factorial is equal to 120. But yeah, that's essentially what a factorial is. It has uses once you learn more like algebra, it's used in combinatorics, but I don't think you guys know what that is yet. But yeah, that's a factorial. You just multiply it by all of the numbers below. So one thing that the UMTYMP exam might ask you to do is to simplify a complicated expression of factor. Oh, am I breaking out, guys? Like, is my audio smooth or is it like
Yeah, it's smooth.
It's smooth.
okay? All right. Sparsh, maybe check your internet then. Okay, anyways, one thing the UMTYMP exam might make you do is simplify a complicated expression involving factorials. So like the example in the handout is 20 factorial over 18 factorial. And you might think, wow, these are massive multiplications that I will not have time to do. So what you should do is look for a clean, simple, quick way to do this. So as the handout says, for this one, you would notice that 20 factorial actually contains 18 factorial inside because it's 20 times 19 times 18 all the way times 1, right? Over 18 times 17 times 16 all the way to 1. And what you should notice here is that this expression is the same as this expression here. And since it's a fraction, they just cancel out. And we're left with 20 times 19, which is 380. But however, this is a pretty simple form. Let me see if I can make one a little bit harder for you guys to try. Let's try 10 factorial plus 8 factorial over 7 factorial. Yes, Tanav?
Does the exclamation point mean like factorial?
Yes, yes. Oh,
Okay.
I should have said yes. The exclamation point in math means factorial. It does not mean to shout the number loudly.
Okay, thank you.
Yes. But see if you guys can solve this question. Wait, this might be kind of hard. Okay, it's probably doable. I'll give you guys like a minute. Yes, Tanav?
Like last class, are we gonna do a mock test?
Yeah, you will. Once I'm done, like we're almost at the end of the lecture and you'll start the mock test then.
Okay, thank you.
Yeah, I will post the mock test and Scantron after Kevin is done lecture. And this time it's going to be a full 50 questions.
Can I ask a question?
Yeah, go ahead.
I don't really understand how to simplify a factorial expression. Can you explain how to do it one more time?
Uh, there's no general way, but I can explain this question one more time again. This is 20 factorial over 18 factorial, if you want me to.
Okay.
So with 20 factorial over 18 factorial, the idea is just if you open up this whole expression, you know that 20 factorial is like 20 times 19 times 18 times 17 times 16 times 15 times 3 times 2 times 1. And then 18 factorial is just 18 times 17 times 16 times 15 times 14 times 3 times 2 times 1. And then since this is a fraction, you'll notice that we can just kind of start canceling out terms. We cancel out this 18 with this 18, this 17 with this 17, this 16 with this 16, this 15 with this 15, and all the way down to the 3, 2, 1. And then we're just left with 20 times 19 over 1, which is 380. So that's how this question is done.
Oh, okay. Thank you.
Yeah. Okay. I think that might have been enough time. I have a correct answer, but it seems like that one was pretty hard. It's fine if you couldn't get it. This question was meant to be pretty challenging. So there's two ways you could go about doing this. You can either just split it into 10 factorial over 7 factorial plus 8 factorial over 7 factorial, or you can try factoring in the top. So with this one, you would notice that oops, that's not how I scroll. Okay, let me move that really quick. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, 3 times 1. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So all of these terms cancel, and we're left with 10 times 9 times 8, which is 720. And then a factorial over 7 factorial is likewise 8 times 7 times 6 times 1 over 7 times 6 times 1. And all of this cancels, and we're left with 8. So adding these together, we would get 728. The other way is pretty much the same thing, but it's just you would notice that 10 factorial is 10 times 9 times 8 times 7 factorial plus 8 times 7 factorial. So then the 7 factorial in all of these would cancel, and we would have 10 times 9 times 8 plus 8 equals 728. So the correct answer for this was 728. But that's like probably one of the more challenging questions that you'll see. I think that's the end of this lecture. So I will pass this on to Aditya to begin the mock test.
Okay. I have the mock test. I'm just going to post it right now. And okay, I have assigned the mock test on to everyone's Google Classroom. So if you go there and take it, it'll be 50 questions and we'll be giving you 30 minutes this time. The UMTYMP test actually has 25 minutes for it, but since this is your first full length practice, we will be giving you a bit more leniency. Okay. It's in the Google Classroom for everyone that you can't get it. You should be in the Google Classroom, as Aaron said at the beginning. It's where we keep everything. So please go to the Google Classroom, and everything is there.
Reload it for it to come.
What'd you say, Enough?
You need to like reload the screen for it to come. Just telling you guys.
I think he's saying that like if you can't see the test yet, try reloading the Google Classroom
Yeah.
page and it should show
Yeah,
up.
that's what I'm saying.
And I will be screen sharing a timer. So, and if you guys are unable to get the links, you have to get into the Google Classroom. I'll ask Eric to put the Google Classroom link into the chat one more time. Okay, that was 30 minutes. You should be wrapping it up now.
Will the homework be posted on Google Classroom?
Yeah, we will post the homework as soon as we are finished with it.
Okay.
And I know last week we went over the questions, but this week, since it is 50 questions and we are running low on time, we will not be going over it. I just think that this was good practice for you. And the next week we will be getting more in depth onto the actual things. And I just think that we had low. Yes, Sparsh, do you have a question?
By E in the questions, did they mean the Euler number or whatever it's called?
Can you say it again, please?
By E, did they mean 2.71?
E means not 2.71, but like the whole thing, 2.71, 828, etc.
Okay.
But that's what E means. Looking at the tests, okay. Actually, I think I'll go over the ones that you guys seem to have missed the most. So it seems you guys missed number 1 the most. I'll share my screen. Okay, let's go over number 1. All right, so looking at number 1. Okay, number 1. So this is actually a good example of Kevin's factorials, where basically you can see here, this is 5 factorials. So it's going to be 5, 4, 3, 2, 1, right? And then from here, what we can actually see is that right here, this can be simplified down to 4 factorial. So really 5 factorial is going to be 5 times 4 factorial. And going over here, we have 1, 2, 3, 4, 5 4 factorials, which we can simplify down to 5 times 4 factorial. So as you can see, these two are going to be C, are going to be equal, and it's going to be C. And then let's look at 2017. We'll go to 17. 17, the number of factors of 24 and the number of factors of 30. So here what we can do is we simply can just write out the factors. So we have 1, 2, 3, 4, 6, 8, 12, 24. So that is 1, 2, 3, 4, 5, 6, 7, 8. 8 factors. How does that 30? Let's look. It's going to be 1, 2, 3, 5, 6, 10, 15, and 30, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, which is 1, 2, 3, 4, 5, 6, 7, 8. So they have the same number of factors, so it would be C. Let me see if there's any particularly tricky ones. Nice job to anyone who got over 30 on this test. That is a really good place to be at right now. And anyone who got below 30, don't worry. That's what we're working to get better at. So don't worry too much about your score right now, because we will be doing more and more practice tests. Oh, it looks like one person got 41 right. So I will be going over 41 right now. 41. Okay, 41 is a tricky one. 41, we can see that Joel swims laps 50 times faster than Sue. So then we can say J is equal to 1.5 times S, right? In terms of lap pace. And so let's look at the number of laps Sue swims in 80 minutes. So in 80 minutes, Sue would swim an X number of laps. Let's just say that. And because Joel swims at 1.5 times faster, this would be 1.5x. Okay. So these are equal. So in 80 minutes, Joel would swim 1.5 times x. Okay. And then so we're just going to convert all of these to Joel laps because we have Joel laps here. Or actually, we'll do Sue laps. So Sue swims an X amount of laps in 80 minutes. Joel swims some number of laps in 60 minutes. So in 60 minutes, we'll call that Y, what he does in 60 minutes. And then because he swims 1.5 times faster, let's just see how much Sue would swim in 60 minutes. So in 60 minutes, Sue would swim. So we have 3/2 is how much times faster Joel is. So we can do 3/2 is times Y times S is going to be equal to Y. So let's just do this, the reciprocal of 2/3 times 60. So we'll have 2/3 times 60, which is going to be divide this 20. We'll have 40 laps. So in this time, Sue is going to swim 40 laps in 60 minutes, which is what Joel swam in 60. Sue would take 40 minutes to swim as many laps Joel swam in 60 minutes. No. Wait 1 second. Okay. Okay, so basically, so here, Joel swims a certain number of laps in 60 minutes. We're going to start from the beginning, actually. So we have Joel swims a certain number of laps in 60 minutes. Okay. So let's see how many laps that is compared to Sue would do in 60 minutes. So let's call it Joel's laps X. Okay, so then Sue in this time frame would swim 2/3 X in terms of lap swimming in 60 minutes. This is how much Sue would do in 60 minutes. So then if this is how much Sue does in 60 minutes, let's see how much Sue is doing per minute. So we have 2x over 3. And then in 60 minutes, she would do this divided by 60. So let's multiply this by 1 over 60. So then we would get x over 90 is how many laps Sue is doing a minute in this case. And over here, we have a certain number. So this would be a certain number of laps over 80. So in this case, because Joel is swimming in a lesser time frame and he is swimming 1.5 times faster, it's going to be B. And so we are running out of time now, so we will be ending class now, and we will be posting the homework. So have a good night, everybody. You can leave.
Thank you.
Bye.
Thank you.